Welcome to JC Connect. Yesterday, we were discussing about the different tests which we are going to conduct on the aggregates. Of course, I will try to finish this overall test, whichever we are going to conduct it on the aggregates. So, in the previous class, we have discussed the moisture content. We have discussed the sieve analysis and some of the impact test. Maybe today we uh, will move a little bit fast because you already covered all this and you already did all this test in two times, maybe in the building material testing laboratory and in the first year of Mtech also you might have did it. So um, we'll just glance it and because still we have pending with the test on the bricks also, that also we will cover it. So we'll move on to the specific gravity. The specific gravity of the it is similar to the water, how we are going to calculate it, but in case of the standard um, or water, or the specific gravity of the water, or the specific gravity of petrol, where how we are going to measure it, there we have to place it. The specific gravity of the aggregate, normally you start with the specific gravity of water, how we are going to calculate it first. So that is specific gravity of water, that can be calculated as the density of the fluid which you are measuring it, then the density of the standard fluid, that is standard fluid we will consider it as water only. The similar way we will find out here the specific gravity of the aggregate also. So then specific gravity of the aggregate, that is equal to weight of the aggregate in place of the density um, of whatever the fluid or the water which you are measuring it, um, divided by the density of the standard fluid, that is water. Similarly here what we are doing is that we are considering it here weight of the aggregate to the weight of an equal volume of water, we are considering it here. So that is WA divided by equal volume of water. So that is weight of the aggregate WA, that is equal to VA into rho W. So then you can put that in terms of the density of the aggregate to the density of water, very simple way. So when you are calculating it for the density of any fluid, we are considering it, normally what we will do is that we will consider the density of um, any fluid which you are measuring it. Take an example of petrol divided by the density of the water. Here also what we are doing is that in place of the density of the given fluid, we are replacing here with the density of the aggregate, and of course the standard fluid we are considering it here for water. But it is, of course it is normally a lot of changes is there when you are considering it for cement. For cement we will use the standard fluid as kerosene. Why we'll use it as a normal kerosene is almost all the your cement is going to be soluble in the kerosene, but in the water it is not going to be 100% soluble. So then specific gravity used in certain computation of concrete mix design or for control works, such as absolute volume of the concrete, absolute volume of the aggregate in the concrete. So it is not a measure of the, of course, quality of the aggregate. With this you won't get any quality, but of course it is interlinked. It's not possible to analyze the quality of the quality of the aggregate with this test, but of course it is going to influence on the strength of the aggregate. So now aggregate impact value test. The aggregate impact value, it gives a relative measure of the resistance to an aggregate to sudden shock or the impact. Here it's very simple. You take an aggregate and suddenly you apply an force or suddenly you apply any weight on that aggregate, then how it is going to respond, that has to be measured here. This is nothing but sudden shock or the sudden impact. This is nothing but aggregate impact value. Then how we are going to conduct it, that is very important. So normally what we'll do is that we'll take the aggregates and suddenly we'll apply the pressure on or the weight on the aggregates. So then we'll see what will be the how it is going to respond with that impact. The property of a material to resist the impact is known as toughness. Of course, due to the movement of the vehicles on the roads, the aggregates are subjected to impact, resulting in their breaking down to a smaller pieces. Normally what will happen is that if continuous movement of the vehicles, it will be there, it may not be any problem. But normally what will happen is that if the vehicle is moving fast, then always the aggregates are coming in contact with a sudden impact on the aggregates itself first. It's normally, if you see any the roads, the first it will come in contact with the aggregate only. When it is, suppose if it is a concrete road, the impact will be mainly transferred to the aggregate first. Suppose if any problem is happened to the aggregate, then of course it will lose its strength. Then there will be a um, breakage, or there will be a breakage of the whole concrete mix. So then, due to the movement of the vehicles on the roads, the aggregates are subjected to the impact, resulting in their breaking down into a smaller pieces. The aggregate should therefore have sufficient toughness to resist their disintegration due to the impact. This characteristic is measured by the impact value test. The aggregate impact value is measure of resistance to sudden impact or the shock, which may differ from the resistance to a gradually applied compressive load. Of course, a lot of difference is there. The gradually applying the stress or the force on the aggregate is totally different from the impact of the sudden load. Sudden load means sometimes the gradual load will sustain some of the aggregates, but even that aggregate should be sustainable or it should resist the sudden impact also. If sudden impact and gradual impact is totally different. Sudden means normally higher forces will be there at a point or a single point, it is going to affect point source. Normally we can call it as a point source load, point source force, or the point source load. So when you apply the force on the point source itself, normally there are many chances that it is going to break it. But of course, if you calculate the total quantity of the load or the total force, if you are going, of course it is a less, but it is a sudden less force with a sudden, it is going to change uh, the affect the quality of the aggregate. So therefore sudden impact is very important, because in most of the time the vehicle movement will be sudden only. The suddenly the vehicle will move and it will lift, it will go to the next point. Suddenly it will uh, press on one point, or suddenly the vehicle tire will touch with one aggregate and it will move, because it will be a movement will be very fast. Always it will be sudden come in contact with the tire and the um, that aggregate. So then we'll move on to the aggregate crushing value. So aggregate crushing value is a test on the coarse aggregate. It gives a relative measure of the resistance of an aggregate crushing under gradually applied compressive load. So previously what we have decided, that is a sudden load, and it is a gradually applied compressive load. And there also it is a compressive strength, here also it is a compressive strength only. That is a compressive stresses we are applying here. It is not a tensile, it is only the compressive stresses or the forces we are applying here. Stress or the force are both are same. Coarse aggregate crushing, coarse aggregate crushing value is the percentage by weight of the crushed material obtained when the test aggregates are subjected to specified load under standard conditions. Aggregate crushing value is the numerical index of the strength of the aggregate, and it is used in the construction of the roads and the pavements. Normally, this value also it is used for the crushing value of the aggregate. Normally, first it is that is the sudden impact test, and this is the crushing value. Secondary it will come. So then 10% fines test. So this is also one kind of test which we are going to find out it. 10%, what it stands for? 10% means in this test what we'll do is that we will take um, some quantity of um, aggregates, and that aggregates should pass through 12.5 mm sieve and retained on 10 mm sieve. So um, then mm, this kind of aggregates are subjected to a compressive load. Then in that compressive load, normally in this we will use one cylinder. In that cylinder we'll apply a layer by layer, that is normally you'll use 3 layers in that cylinders. Then we'll apply a compressive load on that 3 layers. Then when you apply the compressive load on 3 layers, then uh, make sure that 10% fine particle should come out with that quantity of, or the whatever the compressive load you are applying it. Means 10% fine means with that compressive load in that 3 layers, 10% fine it should come. So if 10% fine, if it is fine value, if it is coming after saving it, then note down that compressive load means for 10% fine how much compressive load we are going to get, that can be calculated it. 10% fine means 10% fine, that is equal to 10% of fine, weight of the 10% fine particles divided by the total weight of the aggregate, that can be calculated. So I'll repeat it one more time. So 10% fine, that is equal to weight of the 10% fine particles after applying the compressive load to the weight of the aggregates. Then the 10 test sample is dried in oven after a compressive load, then the weight can be calculated. Then whatever that value is there, that is denoted by 10% fine value. So then aggregate abrasion value. So abrasion is means it is like what, rubbing of the aggregates is a very simple techniques. You take the aggregate, you can do it on your simple hands also. The hands it is not possible of course, but it is like a rubbing the aggregates. When you rub the aggregates, suppose if any dust or if something is coming out, that can be how much it is coming out, that can be taken out, that can be weighed it separately. So the abrasion value of the coarse aggregate may be determined by either the Los Angeles apparatus or Dewell machine. The aggregate abrasion value gives the relative measure of the resistance of an aggregate to wear and tear when it is rotated in a cylinder along with some abrasive charges. So normally in that Los Angeles apparatus, if you see that, so it is cylindrical nature. It consists of many of um, the um, steel balls. That steel balls consist of its own abrasion value. So then we'll add the aggregates of different sieves into that, and we will rotate it, and we'll see, and that aggregate will come in contact with that all balls when it is rotating. Then then normally the aggregate will lose its uh, mm, wear and tear, and we'll find out it how much it is living, or how much it is the dust is coming out, or the how much material it is losing, or the how much quantity of the weight it is losing after doing that all rotations. So then that can be calculated it. But before adding that um, aggregates to the Los Angeles machine, weight properly, then after that revolutions or completing the test, then wait again. That difference whatever it is there, nothing but it is losing its potential, that much potential for uh, for that abrasion value. So then the percentage wear of an aggregate due to the rubbing with the steel balls is determined and is known as Los Angeles abrasion value. Of course we are using here the Los Angeles apparatus. So then abrasion charge. What is this abrasion charge? Is usually that all the balls which are present in that Los Angeles machines, it is having its own charges. Normally the cast iron spears or the steel balls are approximately 40 mm size or in diameter and weighing between 390 to 445 grams. Normally if you see that it is a half kg, roughly each ball consists of half kg. They are normally it's around more than 20 or 30 balls it will be there in that charges. And when it is rotating, the whatever the aggregates it will be there, it will come in contact with that the balls. This is what the Los Angeles machine you might have seen. Maybe we will have one demo in our lab when we come to our after completing the vacation. And you can see that in that Los Angeles palace, it is rotate and the balls it will be there, and the balls will always come in contact with the aggregates when it is rotating. There's also one machine. You can see on the right hand side the different um, steel balls are there, and after that you can see that the fine particles are coming out after rubbing with the steel balls. Then what will the procedure normally we are going to apply it? The test sample consists of the clean aggregate dried in an oven at 105 degrees centigrade and 110 degrees. Normally the wet aggregates may not be used. Normally if you are using wet aggregates, normally that's made of cast iron, the balls are going to rust when your Los Angeles machine is going to be collapsed after some time. So wetted aggregates cannot be used because water should not come in contact with the steel balls. When the steel balls are come in contact with the water, the normally the corrosion will start. Of course, corrosion, of course, oxygen is required. Oxygen will come from the water itself. The sample should conform to any of the gradings shown in table. Whatever the sample is there, that should confirm any of the gradings. That table I'll show you. It will confirm whatever the sample you are taking it. It should follow that standard table. In that standard table, you can see the gradings. In that gradings, it will be A, B, C, D till F is there. So it should follow that all gradings. Select the gradings to be used in the test such that it confirms the gradings in the to be used in the construction and to be maximum extent possible. Normally whatever the gradings what I said is that A to F. So normally it is from 63 mm to 6.5 mm of the aggregates. So then take 5 kg of sample for gradings A, B, C, D, and you can take 10 kg of gradings for E, F, G. So then select the abrasion charges as for the uh, table 2. I already said that each uh, the cast iron balls consist of its each abrasion value. That abrasion value is listed in table 2. I'll tell you what is the table 2 and table 1 is depending on the grading of the aggregates. I already said that the grading of the aggregate is from A to F, it is there. And place the aggregate and abrasion charge on the cylinder and fix the cover. So this is, I'll show you first. This is the table 2. It is nothing but table 2. In this table 2, you can see that the gradings are there, and in that gradings how many steel balls are there. A grading consists of 12 balls, and what will be the weight, what will be the charge on that balls, that will be 5000 plus or minus 25. For B grading it is total 11 balls are there, it is 4584 plus or minus 25. Then C it is 8 balls are there, so then it is 3330. Then for D it is 6 numbers, for E it is 12, and F it is 12, again G it is 12, and the weight it will be similar, that is 5000 charge, that is in gram. And this is the table 1. In this table you can see that different sieve sizes are there, and you have on the Y scale it is a different sieves. It is from 80 to 6.3. I said it is a 63, but you can it will be from 63, and some IS code will say that it is from 63 to 6.3, but some IS code it will say it will be 83 to 6.3. So then weight of the sample retained, and you have to see it. You see that what will be the weight of the sample in a gram retained on mm, that is 63, 50, 40 mm, 25 mm, 20 mm, 12.5 mm, 10, 6.3, that is a 4.75. Then see that on the X scale, if you see it, these are different gradings are there. A, B, C, D, E, F, G gradings are there. In that they have explained that A to D, that is it will be, you have to take it 5 kg. If you see the table here, A table, that is 1250, 1250, 1000, that is total 5 kg. B also you can see that is a total. C also it is a total from 5 kg is there. And if you go to E, F, G, that is a total 10 kg. 2500, 2500, then 5000. So that is total 10 kg. Then F, if you go it is again 10 kg. Then if you go G, it is 10 kg. So this is what the table 1. This is how you have to select it. That only they have told it. See, test sample consists of an clean aggregates dried in an oven at 105 to 110 degrees centigrade. The sample should conform to any of the grading shown in table 1. That is what the table 1 I showed it. So on the Y scale it is a different um, sieves are there, and the X scale you can see that A, B, C, D, E, F. That the tables 2 stands for, that is a charge on each of the balls. So then rotate the machine at a speed of 30 to 33 revolutions per minute. The number of revolutions is 500 for gradings A, B, C, D, and 1000 for gradings E, F, G, H. Of course, here all those balls, whatever for gradings A, B, C, D, you have to rotate it for 500, and for E, F, G, you have to rotate it for 1000. The machine should be balanced and driven such that there is a uniform peripheral speed. The machine is stopped after the desired number of revolutions, and the material is discharged to a tray. So initially you already taken the weight before adding to the Los Angeles machine. Then after this machine, after this revolutions, take it out and sieve it through a 1.7 mm IS sieve. Then whatever the material coarser than 1.7 mm sieve is washed and dried in an oven, and finally the weight can be calculated. Why we will normally wash it means if any dust particle is there, that can be removed, that cannot be calculated. So then how we are going to calculate it? Then original weight of the aggregate sample before adding to the Los Angeles machine, but make sure that it is completely dried. When you are taking it, it should be completely dried, that is nothing but W1. Then weight of the aggregate sample retained, that is W2 grams. Then weight of the passing 1.7 mm IS sieve that is equal to W1 minus W2 grams. So then abrasion value that can be calculated by W1 minus W2 divided by W1 into 100. So then you will get it in percentage itself. Then normal maximum abrasion value in between 32 or to 60% of the various payment can be used, but not more than 60%. If it is abrasion value is more than 60%, then this aggregate is neglected. So in this very important thing is that this table, of course it is a standard table. This is a table um, 2 and this is a table 1. Of course these are all standard, and in the IS code they have mentioned you have to take it 5 kg, or you have to take it 10 kg for ABCD for 5 kg, and EFG AFG you have to take it for 10 kg. Of course many people will take 50% of that, but when you are taking 50% 2.5 kg, you have to reduce it by equally for EFG. If you are taking ABCD for 2.5 kg, you have to take it for 5 kg of E. If you are taking ABCD for 2.5 kg, you have to take it 2.5 kg for EFG. Then equally you have to calculate it with that value. Make sure that whenever you do this test, make sure that it is one right. Okay, then these are the test normally which you are going to conduct on the aggregates. So see the marks in the examination and explain it. Normally this much explanation is not required in the examination. Maybe maximum they will ask it for 10 marks. So each of the test what you can do is that you can you can write the definition of that each of the test, and try to write the IS code, what IS code you are following for that test, and what will the unit of the test, and what kind of equipment will use it for that test. That information is required for each of the test. If that much if you are writing it, then it is sufficient for the sufficient explanation for all those tests. Maybe we will conduct the different types of test on the bricks on the next class.